So just because we've tested doesn't mean that you won't see it again. Okay, so number 5, similar to like one on the test and on the worksheet and on the quizzes and a bunch of other places, right, where it appeared, notes. You have a fraction raised to the -4th power. So we talked about one of the things you could do if you wanted is you could flip the fraction and change the sign of the exponent. That's entirely up to you. It might actually be worth it here because if you notice inside, there are no negative exponents. So although we wouldn't have to flip it, if I distributed the -4 exponent to everything inside, they would all be negative. And then I'd have to bring individual factors down one at a time, right? It's kind of a strategy. So I think that's what I'll do first. I'm just going to say this is now to the +4th, and I have the 5 in the top. And I will go ahead, since I'm writing it, get rid of the radicals. So the cube root of those two factors, remember, we can raise them both to the 1/3. So that's x to the 1st to the 1/3. When you multiply, you get x to the 1/3. And then y to the 2nd to the 1/3, you multiply and you get 2/3. Okay, so that's what the numerator could look like. And then the bottom, we have a 3x squared and the square root of y, which is y to the 1/2. So really all I did was get rid of the radicals and flip it, but I haven't really combined anything yet. Now the inside out approach is again the one that I like, or do I like the outside in? What did I tell you? I forgot what I told you I like. I like them both, you know, because they both work. How about y'all tell me? You want to go outside in or inside out? Outside in? Okay. If you're going outside in, then you would distribute the 4 right now to everything. There are x's and y's to combine on the inside. So I'm putting the 1s on the 5 and 3. So I give myself a target. And now with 6 factors, they all 6 get multiplied, their exponents, by 4. So I get 5 to the 4th, x to the 4/3, y to the 8/3. And in the bottom, you get 3 to the 4th, x to the 8th, and then y to the 4/2, also known as 2. Okay, now we'll simplify. There's really nothing to simplify from high to low. We'll just simplify, I'm sorry, from in the top, there's no x's and y's to combine. In the bottom, there's no x's and y's, so we do combine from high to low. So if you want to use the subtraction rule, which, you know, you can, do your math homework. We get 5 to the 4th, which is the same as 25 squared. 25 squared is 625. You could figure 5 to the 4th out as 625. All over 3 to the 4th, that's like 9 squared, that's 81. Those are not going to have any common factor other than 1, because 625 is 5 times 5 times 5 times 5, which is a prime number, 5. And 3 to the 4th is 3 times 3 times 3 times 3, and 3 is a prime number. So that's as simplified as that gets. Now, because I'm going to use the rule, I'm going to treat that as a coefficient. Just another way to look at it. 6 25th, 81st, what a nice number, times x to the, and now I'll subtract exponents. 4/3 minus 8. Let's see if we can do this in our head. 8 is how many thirds? Multiply by 3 over 3, you get 24, right? So 4/3 minus 24/3. What's 4 minus 24? 4 minus 24? It's 20, right? And that'll be -20 thirds. Okay, again, that's, if you did do it off to the side, 4/3 minus 8 is 4/3 minus 24 thirds. 4 minus 24 is -20. And then I get times y to the 8/3 minus 2. 2 is how many thirds? Multiply by 3 over 3, 6. So 8 minus 6 is 2/3. So that is one final version of the answer. You have a coefficient times x to the power of something times y to the power of something. If you want to clean that up, you could think of those two being over 1. You could then bring the x to the bottom and call it 625 y to the 2/3 all over 81 x to the positive 20/3. Or if you wanted to put them back under a radical, 625 times the cube root of y squared, and then 81 cube root of x to the 20th. Either one of those. All three of those last three are pretty much equivalent. So try to force yourself, especially as we move forward, free up your mental processor for higher order stuff. If you still need to go off to the side to add or subtract fractions, that's okay, but you want to be trying to adopt some of the things that I'm doing so that you can become faster, better, more efficient, right? 1/3 minus 2. 2 is how many thirds, right? 2/3 or 8/3 minus 2. 2 is how many thirds? 4/3 minus 8. 8 is how many thirds? So on and so forth. All right, so there's that one there. That one should be kind of, as we say, old hat, because we've been doing this type of problem the longest, right? It was like the very first type. All right, and then this one. Simplify the complex fraction. It doesn't appear to be a complex fraction, but it is, because you got negative exponents in the numerator and the denominator. So step one, I would say, put all of these over 1 if you're struggling with it, okay? Because now, remember, visually, that gives you a target to get rid of your negative exponent. So this becomes 3y squared over x squared, that's your new top left, minus x cubed y to the first go on the bottom, right? They both go downstairs because both of them have negative exponents. There's your new upstairs. And now in the bottom left, you have 2x squared over y plus 5x over y to the fourth. So just a real quick double check that I get rid of all my negative exponents. 1, 2, 3, 4. I had 5 factors with negative exponents. 1, 2, 3. I have 5 denominators now. Okay, now it's time to multiply by the LCM of the miniature denominators. I have 2 factor types, right? X and Y. So I know I need at least an X and a Y. And then we take the largest or the smallest exponent. The largest. So you look at the X, we have an X squared and an X cubed. 3 is larger than 2. And then you look at your Y's, you got Y, Y, and Y to the fourth, so Y to the fourth. So there's your LCM. Now again, you could put each of these over 1, and now it's time to distribute, right? If we distribute here, you're going to have your x squareds dividing out. You have an x cubed in the top divided by x squared. 2 of them divide out, leaving a single x in the top, right? So what are we left with? We're left with the 3y squared times an xy to the fourth. So that gives us 3x y to the 2 plus 4 is 6. Okay, that's careful inventory. In the next line, when we distribute, now the x cubes completely divide out, and one of the y's divides out, leaving us a 4 times the y cubed that's left. All right, again, that's the strategy. Distribute and divide out, and then whatever's left in the tops gets multiplied together. All right, that's the line right there, that the silence is even more silent than usual. So I don't want to lose it. Let's just multiply like my daughter's middle school teacher said. Multiply straight across. Okay, if you multiply straight across, what are we going to have? We're going to have 3x cubed y to the 6th over x squared. Okay, that's basically multiplying this by this. Minus, multiply straight across. You're going to have 4x cubed y to the 4th all over x cubed y. So instead of dividing anything out, we'll just multiply. And then in the bottom, we'll multiply straight across. We're going to have a 2x to the 5th y to the 4th over the y plus, and then we multiply straight across, 5x to the 4th y to the 4th over y to the 4th. This is another way that you could do it. If the dividing and multiplying in your head is difficult, just multiply top bunk bed times top bunk bed, bottom bunk bed by bottom bunk bed. And then start dividing things out in each term. In this term here, we're left with 3x y to the 6th minus, in this next term, we're left with 4y cubed. In the bottom left, we have 2x to the 5th y to the 3rd. And then in the bottom right, we have 5x to the 4th. So if that's easier for you, go for it. It's still one extra line of writing, but it seems more productive than just writing the thing you're distributing behind each factor. Okay. And you could still do the there if you want. Okay. If you're still struggling with that kind of stuff, you might need to come see me tutorials, and I can just give you like 2 or 3 or 5 or 20, whatever it takes, back to back to back to make sure you get it right. Or one, you may have it in one. All right, now we could be done, but maybe something divides out. So we always want to look to see if it factors in the end. And the first rule of factoring is a common factor. So if I pull out a y cubed in the top, I'm left with 3x y cubed minus 4. And in the bottom, I can factor out an x to the 4th. And that leaves me a 2xy cubed plus 5. Does anything divide out? No, nothing does. So in this case, they're both equally simplified. You know, it depends again on what we're going to be eventually using this kind of stuff for. If we're going to be graphing it, we want like y-intercepts and end behavior, we might want the top version. If we're going to be finding discontinuities, we may want the bottom version. All right, any questions on those two?